been a great pleasure having you here with us, and we look forward to hearing what you have to say this evening. So thank you.
Thank you.
Okay, thank you very much. Now I realise that we are the only thing that stands between you and your next glass of wine. So apologies for that. We'll try and be relatively brief. But thank you for inviting us. Thank you, George, for everything. George, are you still taking video? Okay. I'm just going to start.
Explore the hit. Explore. Do you read? Explore. Over. Explore. Astronaut in all structure. In all structure. Still intact. Once you pass. Don't pass that on to the carry you too far. My boy. In the focus. Seconds of the way to try. Leave this intact. Do it anymore. Do it now.
Okay, hands up if you've seen Gravity. Right. So you'll agree with me that as a film, you know, film with plots and acting, and it's a disaster. But as a piece of applied mathematics, it is an absolute work of genius. The first 9 minutes were produced in London. The other London. We're terribly proud of it. But I've done an informal research project on this. I show this to people of all ages, kids and adults. And I say, do you have any idea how this was done? And they say, sure, it's virtual reality. And they say, yeah, but what does that mean? How is it actually done? And when you dig down, how it's actually done, according to most people, is there are these things on the screen called pixels, and you make them go light and dark, color this color or that color, and it's like painting a picture, only it's done with pixels. And nothing could be further from the truth. Every single particle that you saw, or at least until we turned the lights out, you couldn't see anything about it. Every particle of matter that you see was directed by the laws of physics. And this really is a virtuoso piece of applied mathematics. In the CGI industry, there are people who spend their life studying how, they actually have a title which escapes me. They study how light bounces off skin.
Rendering.
Yeah, there is a skin word for it. Anyway, how light works is it goes quite a few layers into the skin before some of it leaks out. And that's why skin is so difficult to render on CGI. And there are people who spend their entire time modeling the behavior of a bunch of hair as the owner of the hair runs along a stream. So this is mathematics and its applications in this current period. And not to understand that this is applied mathematics, to believe that it's just bits of pixels on a screen, is a dangerous matter. I'm going to make the connection for you, you'll make it yourself. I'm going to show you something that happened in 2007, which was the year of the banking crash. It was our banking crash. You guys were too sensible to have a crash, I gather. And the chief executive said, chief executive financial officer, please note, said we were seeing things that were 25 standard deviations several days in a row. Now, I don't have to tell you what 25 standard deviations is. It is halfway to the other London. And in case you want to know more about the figures, the expected waiting time for an event of that kind is 10 to the power 127 times the life of the universe. And this guy was a little bit shocked that it should be happening 3 days in a row. At no time is it reported that he said, perhaps we're using the wrong model, perhaps we should interrogate the model that we're using, perhaps life isn't continuous, perhaps, well, there's lots of perhapses that you can imagine. So the connection I'm making, I'll make it for you in case it's not already clear, is that by not understanding that what a model is, you can get yourself into serious trouble, and the financial system in this case got itself into serious trouble because it assumed a nature of a model that was just unassumable. Okay, so everything changed in the UK when this man visited us because he's a personal friend of our Prime Minister, who was then the leader of a coalition government, is now unfortunately leader of the government in the UK. But don't get me started on that. He was surprised that we don't teach our kids how to program computers, and sure enough, he was right. We had these things called ICT, Information and Communication Technology lessons, at which key pieces of information for our 21st century, such as how you plug a computer into the wall, were taught, how you make a cell in Excel go bold instead of standard, and how you can do unfeasible things with Word. In other words, not computer science at all, not coding, just some kind of, somebody's warped understanding of what computer literacy might be about. And because he's one of the richest men in the world, and our Prime Minister likes money, things started to change. We had a national movement to bring back programming and computer science for kids of all ages. And there was a national computing curriculum introduced more or less summarily. He actually said, as of now, I'm abolishing the ICT curriculum, and there will be a new curriculum in 9 months' time. Now, if that happens, you can see that there are problems built in, like who's going to teach this curriculum, what will this curriculum actually consist of, why are we doing this? Is it because we really and honestly believe that there are going to be hundreds of thousands, maybe millions of jobs for people to program computers in the 21st century? Because that isn't going to be true. There will be a huge amount of programming power used, human labor power, but it won't translate in any kind of linear way to the number of people that will be employed. But still, Celia and I woke up that one morning and said that our dream has come true. We've spent longer than 35 years trying to hijack the computing agenda in the cause of mathematics and trying to understand better what might become of mathematics learning and teaching if we could assume that people had ready access to computing. I should just say that in 1975, I attended a conference of maths educators, maths teachers, at which the issue for debate was, what would we ever do in a world where it was possible that every child could have a calculator? And 3 years later, every child had a calculator, and the Earth didn't stop moving, actually. We still don't really know what to do with calculators. Okay, so I just run these past your eyes. I'm not going to say anything about them. Lots has happened. Money has changed hands. There's a network of master teachers happening right now. And things really are moving. And it is an amazing opportunity for us in the UK. And I've heard that some of you are envious of what's happening in the UK. It's not all great, but hopefully we can